So here in this problem, we need to determine the equation of a circle having a radius of 6 units. And the circle is tangent to the x-axis at a distance of 5 units from the origin. So let's first try to understand the problem graphically. So here we have the Cartesian plane with the x-axis and the y-axis. Now in the problem it's given here, the circle is tangent to the x-axis, meaning the circle is going to touch the x-axis at a distance of 5 units from the origin. So let's suppose that it's 5 units from the origin. So this is the point x equals to 5. So our circle is going to be tangent to x equals to 5. Now since the radius of the circle is 6 units, it's definitely going to intersect the y-axis as well. So here we have the circle. So let's consider the center of the circle to be h, k. And its radius is given. So the radius of this particular circle is 6 units. Our task will be to determine the equation of this circle. For this, we're going to use the standard equation of a circle, because if in the standard equation of a circle, all we need is the information about the coordinate of the center and the radius of the circle. So let's first specify the standard form of a circle. So if we have a circle whose center has the coordinate h, k and a radius of r, then the standard form of a circle is given by the equation x minus h whole squared plus y minus k whole squared equals to r squared. Now let's try to find out the center. So we have denoted here, let the center of our circle be denoted by the coordinate h, k. Here we are given the radius of the circle. It's given that the radius of the circle is going to be 6 units. Now what we'll do, we'll drop a perpendicular from the center, let's call the center as C, on to the x-axis. So this is going to be the perpendicular, and the length of this perpendicular is going to be 6 units, because that's nothing but the radius of the circle. Now that means we have the height, which is also the y coordinate of the center C. Now we have immediately found out the value of k. So here the value of k comes out to be equals to 6 units. Now our task will be to find out the x coordinate of the center. Now that's also easy, because it's given here that the x coordinate is 5, because the center is 5 units away from the origin. So since this distance is 5, so we have the h value as 5 as well. Now that we have the value of k, h as well as r, we can use the standard form. So now we will get x minus h, so h is 5, x minus 5 whole squared plus y minus k, so k value is 6, y minus 6 whole squared, and this is going to be equals to the square of the radius. So we have successfully found out the equation of the circle, which has a radius of 6 units, and it is tangent to the x-axis as a distance of 5 units from the origin. Now the question is this the only circle that's possible? Think about it. No. There will be, in fact, 3 more circles that satisfies the same criterion, because all it says that the circle is tangent to the x-axis as a unit of 5 units from the origin. It says nothing about its orientation. So that means it could be 5 units from the origin to the left of y-axis. That means along the negative x-axis. So we have x equals to negative 5. So here also the circle can be tangent to the x-axis. It can be below the x-axis as well, or both the positive x-axis and the positive y. Let me show it with the help of a diagram. So here we can observe that there are indeed 4 circles. We'll start with the yellow circle, which lies on the second quadrant. Now we'll need information regarding the coordinate of its center. For the circle present in the region number 1, or the first quadrant, you've obtained that the center is given by 5, 6. Here both h and k value are positive. Now in the second quadrant, it's going to be negative 5, 6. We'll have to consider the x coordinate to be negative, since we are on the negative x-axis. Coming to the circle in the third quadrant, which is the pink circle, here we have negative 5, negative 6, and that's going to be the coordinate of the center, because we are lying on both the negative x as well as the negative y axis. And the circle in the fourth quadrant, which is the green circle, this is going to have the coordinate of the center as positive 5, because we are on the positive direction of the x-axis, and then we have negative 6, since we are along the negative direction of y-axis. Right. So we can find out the center which I've already done here, and the radius is going to be fixed. The radius for each of the 4 circles is going to be 6 units, and we can use the standard form to find out the equation of the remaining 3 circles, which I'm leaving as an exercise for you to try out. So hence we have successfully found out the equation of a circle, which is having a radius of 6 units and it is tangent to the x-axis at a distance of 5 units from the origin.